Good morning everybody, I am Sridharreddy. Today my topic is Graham diffusion law and Dalton's law of partial pressure from the kinetic gas theory. Means that by using the kinetic gas theory, we have to derive Graham diffusion law as well as the Dalton's law of partial pressure. I am taking the Graham's law. Graham law gives you relation between the rate of the diffusion and the density at the given temperature and the pressure. At the given temperature and the pressure, it gives you the relation between the rate of the diffusion and the density. What is the statement? At the given temperature and the pressure, the rate of the diffusion is inversely proportional to the square root of its density. Nothing but R is proportional to 1 by root D. At the given temperature and the pressure, or temperature pressure is constant. This is called the Graham diffusion law. Now you have to prove this one by you taking the kinetic gas equation or kinetic gas theory. What is the kinetic gas equation or theory? If you observe, PV is equal to 1 by 3 mn c square. So this is the equation which is called as the kinetic gas equation. By using this equation, now you have to derive R is proportional to 1 by root D. Then we can say we derived the Graham diffusion law by taking the kinetic gas equation. Now look at here. I am taking the 3 this side. Immediately you will get 3 PV is equal to mn c square. M is the mass, N is nothing but number, 1 mole, 2 mole, 3 mole. Ultimately 2 moles, 3 moles, 4 moles mass only. Ultimately M into N, nothing but 2 moles of mass, 3 moles of the mass. Ultimately it gives you mass only. That's why I am taking it as a 3 PV is equal to capital M C square, since M into N will give you the mass only. Now C square I am writing. C square is equal, nothing but I am sending the M this side. Immediately you will get 3 PV by M. C square is equal to 3 PV by M. Ultimately C is equal to under root of 3 PV by M. Now look at it. Rearranging this equation. V by M. Already we are familiar. Density is equal to mass by volume. But volume by mass nothing but 1 by D. Ultimately we can written as 3P by D. Look at here. M by V is equal to D. V by M is equal to 1 by D. If you observe, 3 is the constant, pressure is the constant. Ultimately we can written as C is equal to constant into 1 by root D. C is equal to constant by root D, nothing but C is proportional to 1 by root D. Let us give equation number 2. But what is my aim? My aim is to show R is proportional to 1 by root D, not C is proportional to 1 by root D, where C is called as the RMS velocity. Now, what is the relation between the RMS velocity and the rate of the diffusion? C is directly proportional to the R. Velocity increases, rate of diffusion also increases. Ultimately, by taking the equation 2 and 3, we can say C is proportional to 1 by root D, C is proportional to R. Ultimately, R is proportional to the 1 by root D, which is called the Graham diffusion law. So based on, we are taken the PV is equal to 1 by 3 mn c square, which is called the kinetic gas equation. By taking the kinetic gas equation, we proved R is proportional to the 1 by root D, nothing but rate of diffusion is directly proportional to the 1 by the inversely proportional to the square root of its density. Now once again we will take 1 by 3 mn c square. I am taking the 3 this side. Immediately 3 PV is equal to mn c square. M into N nothing but ultimately it gives you mass only. That's why I am taking the capital M C square. C square is equal to 3 PV by M. C is equal to under root of 3 PV by M. But density is equal mass by volume. But volume by mass is given as the 1 by D. Ultimately 3 is constant, P is constant. Ultimately C is equal constant by root D. Ultimately we will get C is proportional to the 1 by root D. But we have to show R is proportional to the 1 by root D. That's why what is the relation between the C and R? C is directly proportional to R. Velocity increases, rate of diffusion increases. By using the equation 2 and 3, we can say R is proportional to the 1 by root D. Based on this one, we can say at the given temperature and the pressure, the rate of the diffusion is inversely proportional to the square root of density, which is called the Graham diffusion law. Now I am taking the Dalton's law of partial pressure. What is the Dalton's law of partial pressure? The pressure extended by the mixture of the gas equal to sum of the individual pressures. Each individual pressure is called as the partial pressure. The pressure exerted by the mixture of the gas equal to sum of the individual pressures is called as the Dalton's law of partial pressure, which also can be derived by taking the kinetic gas equation. Now, in taking the kinetic gas equation, PV is equal to 1 by 3 mn c square. Let us give equation 1 by taking this one. Now we have to prove P is equal to P1 plus P2. Let us take, I am taking a vessel which is filled with a gas which will have the N1 moles of the gas. N1 moles of the gas. N1 moles are the first gas. The mass of the gas is M1. Number of moles is N1, RMS velocity is C1, and the volume of the gas is the V. Because vessel is the vessel volume will be the V. The pressure exerted by the gas, let us say P1. So P1, M1, C1, N1, and the volume is the V. According to this gas equation, we can say P1 V is equal to 1 by 3 M1 N1 C1 square. Now I am calculating the P1. P1 is equal to 1 by 3 M1 N1 C1 square by V. Let us give equation number 2. Now, same vessel is replaced with the vessel is the same, volume is the same. Now it is replaced with the another gas whose number of molecules is N2, number of mass is C2, RMS velocity is C2, the pressure exerted by the gas is the P2. According to this equation, we can write as P2V is equal to 1 by 3 M2 N2 C2 square. So P2 is equal to 1 by 3 M2 N2 C2 square by V. Let us give equation number 3. Third. Now, I am taking the same vessel. Now it is filled with the mixture of the two gases. Mixture of the first two gases. Nothing but N1 moles are the first gas, N2 moles are the second gas. This mixture is taken in the same vessel, and the pressure exerted by the mixture of the gas is P, and the number of moles, if you observe, N1 and N2. This N1 gas will have the mass is M1, RMS velocity is C1. N2 gas will have the mass is the M2, RMS velocity is C2. Now, according to this equation, the pressure exerted by the gas is P, mixture. So, PV is equal to. So, it is the 1 by 3 MnC square. What we will write? First gas is the 1 by 3 M1 N1 C square plus 1 by 3 M2 N2 C square. Because it is the mixture of the two gases. First gas will have M1 N1 C1. Second will have M2 N2 C2. The pressure exerted by the gas is P and the volume is the V. Ultimately, P is equal to, I am taking this one as the 1 by 3 M1 N1 C1 square plus 1 by 3 M2 N2 C2 square by V. Now, P is equal to, I am separating this one, 1 by 3 M1 N1 C1 square by V plus same 1 by 2 1 by 3 M2 N2 C2 square by V. P is equal to, according to the equation 2, P1 is equal to 1 by 3 M1 N1 C1 square by V. So P1 plus P2. Nothing but P is equal to P1 plus P2. We are taking the kinetic gas equation theory and we derived the Dalton's law of partial pressure, which is called as the pressure exerted by the mixture of the gas equal to sum of the individual pressures. Each individual pressure is called as the partial pressure. For what we are taken, very simple. We are taken the vessel. First it is filled with the N1 moles of the first gas. Then it is replaced with the N2 moles of the second gas. Then we are taken the first two gas mixture, N1 moles of the first gas and N2 moles of the second gas. The pressure exerted by the mixture of the gas is P. Ultimately, PV2V is equal to mixture of the two gases. So separate this one. This gives you the P1 and this gives you the P2. Ultimately, we derived the Graham diffusion law as well as the Dalton's law of partial pressure by using the kinetic gas equation, which is called as the PV is equal to 1 by 3 Mn C square. Thank you.